focusing on objective number 2 of section 2.3 in this video, which is being able to use our graphing calculator to come up with a line of best fit for our data set. In our previous video, we took this data comparing relative humidity and apparent temperature and came up with a linear equation by hand to represent the data. All we did was we chose 2 points from the data set and built the equation from there. Okay. Now understand that choosing 2 different points from our data would give us a different equation most likely. And the question becomes which equation or which line is best for the data. Well, that's where a statistical approach to find what's referred to as the linear regression equation or line of best fit can be used. We're not going to do the statistical approach by hand ourselves. We're just going to allow the calculator to do it for us. It's been programmed to be able to do it for us, okay? So obviously you're going to need your graphing calculators out. First thing we're going to do is reset our memory so that everyone has the same settings before we move into our example, okay? So let's hit the second button on our calculator, then the plus sign. It'll take you to the memory menu. You want option 7 for reset, then option 1, and then option 2. So now our memory has been cleared, okay? All right, now, next is very important. After clearing the memory, we have to tell the calculator to turn the diagnostic on. And I'll explain more later on in the video as to why this is necessary. In order to turn the diagnostic on, you're going to go into the catalog menu. Hit second 0, and the catalog menu is an alphabetical list of every command that the calculator is programmed for. So obviously we're in the A's right now. We need to get down to the D's. The nice thing is when you engage the catalog menu, see how we have an A up here? That means our alpha lock is on, and the alpha lock corresponds to the numbers assigned to each button. Well, we want to be to the D's, so D is assigned to this button. Hit it, X to the negative first, will take you down to the D's. From there, you can just use your down arrow to go down to diagnostic on. Once you're there, I want you to hit enter, and then hit enter a second time, and it'll say done. Okay, that means we have turned the diagnostic on. Doing this will allow all the numbers that we need to see for our example today to show up on the screen. Okay. All right, now we're to a point where we can input our data into the calculator. So let me go back. Here's the data set. To put this into the calculator, you're going to hit your stat button, and you want to edit your lists. So choose option 1, and your lists should be empty right now since we cleared our memory. If for some reason you had numbers already in your list, let me just put a few in here. Rather than like deleting each one separately, you can highlight the list, which is in this case list 1. Once that's highlighted, hit clear and then enter, and notice it wipes out the list. Okay. List 1, we're going to input our X values, so take a moment to do that. After you type in each number, you're going to hit enter. And always when you're done typing in to a particular list, go back and check to make sure you don't have any input errors. I find that I quite often do. Okay, so that list looks good. Then use your right arrow to get over to list 2. List 2 is where you put your Y values. Okay. Once your data is in your list, what we'd like to do is see the scatter plot associated with this data set. So if you hit graph right now, it's going to take you to a blank coordinate plane. That's because the values that correspond to each point in our data set, they don't match the scale of the x and the y axis right now. Okay, so a couple of things we can do to get that scatter plot to show up for us. We're going to go into the stat plot menu. So we hit second y equals, and see right now plot 1 is off. We want it to be on, so we're going to hit enter, and we want to highlight on. So hit enter again. Now it's turned on, and notice the type of graph that's been defaulted to is a scatter plot, so we want that to stay. And then it's pulling our x values from list 1, our y values from list 2, which is exactly how we input our data. Okay, now if you hit graph at this moment, you're still going to see the same graph, a blank coordinate plane. What we'll do now is use the zoom feature of zoom stat. So hit your zoom button and then choose option 9, and that will adjust the viewing window on the graph based on the numbers that you put into your stat lists. Okay, so now we see all those points from the data set. If we use the trace button, we can then use our arrows to cycle through and see the different points in the data set. Okay, all right, now what I'm really after though, I don't just really want to see the points on the screen. I want to see the equation that matches the data set. It's called the linear regression equation. So these are the steps to come up with that equation. You're going to go back into the stat menu, so hit your stat button, and you want to go over to calculate. So you hit your right arrow, and then under the calculate menu we want option number 4, which is linear regression. Okay, option 4. It's telling me that my x and y values are coming from list 1 and list 2. I like that. And then we're going to tell it to, once it comes up with the equation, we're going to tell it to store the regression equation into y sub 1. Okay, so get your cursor here, hit vars, which is short for variables, go over to y variables. You want option 1, and once again option 1 for y sub 1. So what that's going to do is once I calculate the equation, it's going to store the equation into y sub 1 under your y equals menu. Okay. All right, now we hit calculate, and the calculator spits out this screen. Notice I have y equals ax plus b, that's a linear model, and I have a value for a and for b. So based on the model, a is representing my slope and b is representing my y-intercept. I have that copied on your screen as well, on your graph or on your notes. Okay, so my slope is approximately 0.121. My y-intercept is approximately 64.409, making my equation for the line of best fit as you see here. Okay. Notice you have two other values as well. You have an r squared value and an r value. This is why we turned the diagnostic on. Had we not turned that on, you wouldn't have seen these two numbers. So that's important moving forward. If you're working with any other data set and you don't see these two numbers, then that means you need to go through and turn that diagnostic back on. Okay, I'll talk about those numbers more here in a minute. Notice if I hit y equals, I have the equation, the non-rounded version of the equation, stored into y sub 1, so that now when I hit graph, not only do you see the scatter plot, but you also see the line. Okay, and that's useful, that's helpful, because now we can tell the calculator to evaluate the linear equation with a specific value of x. Recall in our previous video when we made our equation by hand, once we did that, we used the equation to find the apparent temperature based on the relative humidity being at 35%, right? So we plugged 35 into our equation for x and then simplified. And this is the value that we got. Well, we can do the same thing on the calculator, okay? You have two options. Your first option is just simply plug 35 in right here into the rounded version of your equation. The thing is, though, those are rounded numbers, so you'll get a slight rounding error, okay? If you use the calculator, you'll get as an exact of a number, as precise of a number as you possibly can, okay? Well, how do we do that? You're going to use the calculate menu. You'll hit second, trace. It takes you to the calculate menu, and we want option 1 for value. That'll then take you to your graph with the scatter plot and the line, and it's letting you plug a value in for x. So we're going to put 35 in, and we're going to hit enter. Notice it spits out a point on the graph whose y value is 68.64. Okay, so this is the apparent temperature outside when the relative humidity is at 35%. Notice it's pretty close to the value that I got by hand, but the calculator's version is a little bit more accurate. Okay. All right, so let's go back, and I want to pull this up, this screen again. So now let's talk about r squared and r. Okay. These numbers will tell you just how good of a relationship you have in your data set. For the purpose of our course, we're not going to focus on r squared, so we're going to ignore that. But let's talk about r. Our value for r is 0.994, and this number is called the correlation coefficient. R is known as your correlation coefficient, and it measures the strength of the linear relationship between the two variables of your data set. Here are the rules for r. R is always going to be a number between -1 and +1. The closer r is to +1, the stronger the positive linear relationship in your data set. So our r value is really close to 1. That means we've got a pretty strong positive linear correlation. Okay. Let's say r is really close to -1. That means you have a strong negative linear relationship in your data set. If r is not close to 1 or it's not close to -1, the closer r gets to 0, the weaker the linear relationship in your data set. And that would mean you would probably want to fit your data with a different type of equation. Okay. All right, so to drive this home, I want to pull up this illustration. Okay. So here you can see I have a scatter plot with a linear regression equation already on the screen. Here's the equation itself, and then here's an r value. So right now the r value, it's not really showing a very strong linear relationship. 0.49 is not a strong linear relationship, okay? That's because these points are, fairly spread out. Notice if I move these points closer together, see how this r value is getting larger. It's getting closer to 1. Now the only way it would get to exactly 1 is if I actually had a true straight line. Okay, all of my points formed a straight line. Okay. You can see as I move these points further apart from each other, see how these the r value is going to get closer to 0. Okay. And then let's say I change the trend here. Let's make my trend a downward trend. Now notice the r value is negative, and see how I have negative 0.96 right now. That is showing a pretty strong negative correlation in my data set. Okay, so hopefully that's a nice visual for you of how the positioning of the points affects both the equation itself and that correlation coefficient. Okay, all right, that's all for this video.